Alright, this first video for section 4 pairs of angles is just going to kind of be an introductory video talking to you about identifying angle pairs and different things like that. Okay, so this isn't specifically in your packet, but they're things that you need to know. Okay, so the first thing we're going to talk about is how to identify an adjacent and find adjacent angles and angles that form linear pairs. Okay, so there's several things that you need to happen. Okay, so one, you need to have a common vertex between the two angles, so a common vertex. Okay, the second thing is that they need to have a common side. And third, you must have them be opposite rays. Okay, so for the above example, you have angle ABE and angle EBC. The first thing we need to see is if they have common vertex. Okay, so if you have ABE and you have EBC, you see that they both have the vertex right here. Okay, so that's done. Okay, then you have to see if they have a common side. You see that they both go from this segment EB, so you know that they have a common side, and you know that they make a opposite ray because both of them have one of their lines go off either side. It makes a collinear line, which then results in an opposite ray. Okay, so you have all these things, so you know that you have angles that are adjacent, and they also form a linear pair. Next, we want to see if angles are only adjacent. They don't have to have a linear pair. Okay, so if you want to have it just be adjacent, you only have to have two things. You have to have a common vertex, and you also have to have a common side. Okay, so if you look at angle ABE, let's go ahead and trace that one in red. You have ABE, and you have EBD. You'll notice that they both intersect, or the vertex is at B, so you know that stipulation 1 is taken care of. And if you look, you have segment EB. I'll go ahead and highlight that a little bit. That is a common side. Okay, but you'll notice that there aren't 3 points on the same line on this, so it doesn't form a linear pair, and therefore it doesn't have it doesn't have a linear pair, and it doesn't make an opposite ray. So we know that it's not an adjacent angle and a linear pair. This time it's just an adjacent angle. The last type you could have is if two angles are not adjacent. Okay, so if it's adjacent, you know that they share a common vertex and they also share a common side. But if you look at these two angles, CBD, which we're going to highlight, and ABE, you'll see that they do have a common vertex, which is one of your stipulations, but it doesn't share a side. So we know that this is not adjacent. The only other two things that you need to know in this section are about complementary and supplementary angles. Okay, we'll go ahead and start with complementary. Those are angles where if you have two angles that have the sum of 90 degrees, you know it's a complementary angle. So for example, if you had an angle that was 37 degrees, and if you had another angle that was 53 degrees, you know that those angles are complementary because if you add 37 and 53, you get 90 degrees. Okay, so any two angles that add together to be 90 are going to be complementary angles. The other type is supplementary angles, and that's when two angles have measures that have a sum of 180 degrees, or you have two angles that when you add up their measures, they add up to 180 degrees. So for example, if you had an angle with measure 127 degrees, and you had another angle with measure, it's a bad picture, a measure of 53 degrees, if you add up 127 and 53, that will give you 180. Okay, so anytime you have two angles and their measures have a sum of 180 degrees, you know that you have supplementary angles. Okay, so in this section you need to know complementary, you need to know supplementary, you need to be able to tell if angles are either adjacent and form a linear pair, or they are not adjacent. So just those few things you need to know. Take a look at the second video that's below this, and it will go further into those things.